Course 3, talking about properties of equality today and how we can solve algebraic equations with them. An equation, a statement with an equal sign stating that two things are equal, two sides are equal, is a lot like a scale. If two things on a scale are equal, that means, that both sides will be level, that this will not tip either way. And if we want things to stay equal, so we're not lying by having this equal sign here, if I remove a 5, I have to remove 5 from this side too. Right? That's just how a scale would work. And when I do that, you take this 5 away, you take this 5 away. If we're still equal, well then what does that say about this box and what this mystery amount is? Can you tell what that is? Wouldn't it be the same as this? Because the scale is still level and we've removed everything else. That means x must be the same as 7. We have literally a 7 on one side and a 7 on the other. This is the algebraic equation version of what I had up there. An x and then a 5 equaling a total of 12. So they talk more about that, and here are your properties of equality. You can add the same thing to both sides. Add c to both sides, it stays equal. Take away c from both sides, still equal. Multiply c, divide c. All of these are properties of equality, operation properties. After spending $2.30, so spending, it means subtracting the $2.30 from, we don't know how much he started with, but he ended up with $5.70. How much money did he have at the beginning? Sort of like a sum someone away problem. How could we get x alone so that we can figure out what is its value? Because it's going to be the same as whatever's left over here. How do I do that? I need to add $2.30 to this side so that it's just x. But if I add something to one side, I add it to the other, and now I've got 7 plus $1, $8, equaling just x. Now I know what Robert had before he spent. They show you how they did that there as well. You can do the same thing with multiplication. With division, let's try that. Solving 2/3 of w is 3/4. If we want w to be alone, so I know exactly what it's worth, right? That's ultimately what I want, is I want w by itself equals, I don't know yet. To get w by itself, which would be, w by itself really just means I have one w. That's what w means. So can we get 1w out of 2/3? How do I make 2/3 a 1? I multiply it by its flip, by its reciprocal, right? So if I multiply 2/3 w by 3 seconds, that's going to all cancel. But if I do something to one side, I'm going to do it to the other side too. I had 3/4 over here before, right? So I do the multiply there as well. Now I've just got this 1w. 3 times 3 is 9. 4 times 2 is 8. And that's what algebra looks like. This really doesn't need to be here. It's an invisible 1. Didn't we learn that? So w is 9/8. Better 1 1/8. Which is what they have there for us. So those are called the operation properties of equality. We're using opposite operations to ultimately solve. You would add 2 3/10 to get x by itself in that case. So what does it mean when we isolate the variable? That's what I mean every time I say, can I just get x by itself? So it's just x is whatever it's worth, right? That's isolating it. Now it's just x here, isolated. equaling whatever it's worth. The inverse means the opposite operation. So for subtraction, that's addition. For multiplication, that's division, right? Why don't you solve D, E, G, and pick one of these for 4 total problems, please. Thank you.